Hello and welcome to another video with Liah. Today we're going to be talking about molecular geometry. If you're new here, make sure to subscribe and hit the little bell for notifications when I post a new video. Now if you find this video helpful, please remember to leave a comment down below. Molecular geometry, or VSEPR theory, which stands for valence shell electron repulsion theory, is basically just talking about the shapes that molecules make depending on the repulsions between their lone pairs of electrons, and in turn the repulsions will determine what shape a molecule will take between its central atom and the atoms bonded around it. So basically the shape is based on the electron pairs bonded to the center and how those electrons affect the position of the atoms bonded to the center atom. Before I start showing you the shapes, here I have three letters. A is going to stand for the central atom. X is going to be an outer atom that is bonded to the central atom, A. And E is going to represent a lone pair of electrons around the central atom. In this column here, I have the general formula, which tells us the number of outer atoms and the number of lone pairs around the central atom, A. Then I have a drawing here of what that can look like, and then we will be figuring out the molecular shape and the electron pair geometry and the bond angle. So for this one, we have AX, which means we have one central atom bonded with one outer atom. The molecular shape here is going to be linear, as is the electron pair geometry. So both of these are going to be linear. For the bond angle, we can see that we basically have them in a straight line, and we know that a line is 180 degrees. Next we have AX2, so one central atom surrounded by two outer atoms. This is also going to be linear, and the bond angle again will be 180 degrees. For AXE, we have one central atom, one outer atom, and one pair of lone electrons on the central atom. This one is going to be linear again, and the bond angle here between these is going to be 180 degrees. Now moving on to AX3, this is when we have three things bonded to A. So in this case we have three outer atoms bonded to the central one. This we call trigonal planar. For the electron pair geometry, we also call this trigonal planar. So you can notice here that when we have no lone pairs, no E, the name for the molecular shape and the electron pair geometry are going to be the same. And now for the bond angle, so the bond angle between these atoms is going to be 120 degrees. Now we have AX2E, so we have one central atom, we have two outer atoms, and we have one lone pair of electrons on A. The molecular shape here, we call it bent. And the electron pair geometry, trigonal planar. So notice here that for molecular shape, we are counting only this part. So we are only counting the atoms, while in electron pair geometry, we count the shape that the electrons and the atoms make around A. For the molecular shape, we're just counting just the outer atoms and the central atom and seeing what shape that makes. Alright, and for the bond angle, we're also going to have 120 degrees because we are basing it off of the electron pair geometry. Now for AXE2, which is one central atom bonded to one outer atom, and we have two lone pairs of electrons around the central atom. And so the molecular shape, knowing that we just count the atoms, is going to be linear, and the electron pair geometry is still going to be trigonal planar. Because remember, we are also counting the lone pairs of electrons, as well as the outer atom. and the bond angle for this is going to be 120 degrees. Now moving on to where we have 4 groups around A. AX4, we have 1 central atom, we have 4 outer atoms. The molecular shape is going to be called tetrahedral, so tetra for 4, and we're also going to call the electron pair geometry tetrahedral. And the bond angle between these atoms is going to be 109.5 degrees. Next we have AX3E, so we have 1 central atom, we have 3 outer atoms, and we have 1 lone pair of electrons on the central atom. For this one, the molecular shape is going to be called trigonopyramid, and in some classes you might see trigonopyramidal. The electron pair geometry is going to be tetrahedral, because there are still 4 groups around the central atom, 1 lone pair plus 3 outer atoms. The bond angle is going to remain at 109.5 degrees. For AX2E2, we have 1 central atom bonded to 2 outer atoms, and we have 2 lone pairs of electrons on A. The molecular shape for this is going to be bent, and the electron pair geometry is going to be tetrahedral, and the bond angle is going to remain at 109.5 degrees. For AXE3, we have 1 central atom, 1 outer atom, and 3 lone pairs of electrons around the central one. And so this molecular shape is going to be called linear, right? Just counting the angle between X and A. And then we have the electron pair geometry, which is going to still be called tetrahedral. The bond angle for this is going to be 109.5 degrees. Remember, we are counting bond angle between all of the groups, so the lone pairs and the atoms. Next we have the geometries with 5 groups around the central atom. So for AX5 we have 1 central atom surrounded by 5 outer atoms. The molecular shape and the electron pair geometry for this one is going to be called trigonal bipyramid, or trigonal bipyramidal, depending on the class you take. They're both going to indicate the same thing. And the bond angle for this is going to be 90 and 120. So what I mean by that is that between these two, the angle is going to be 90. You can see this, there's kind of like a right angle here. And between these 3, that bond angle is going to be 120. Alright, moving on, AX4E, we have 1 central atom, 4 outer atoms, and 1 lone pair of electrons on the central one. And so here, the molecular shape is going to be called seesaw. You can kind of see here, like, these are the legs, and then here's where you could have put something. And the electron pair geometry is still going to be trigonal bipyramid. The bond angle is still going to be the same, 90 degrees and 120 degrees. Remember, 90 degrees will apply to this one and this one, so right here, and between this one and this one, so 90 degrees here. 120 degrees is still going to be the same between these two, and between the lone pair and this atom, as well as this atom over to this lone pair. AX3E2 has 1 central atom, 3 outer atoms, and 2 lone pairs on A. The molecular shape for this is going to be called T-shape. You can kind of see that, right? So here and here, the T there. And the electron pair geometry, because there are still 5 groups around A, it's going to still be called trigonal bipyramid. And the bond angles are 90 and 120. Now we have AX2E3, so 1 central atom, 2 outer atoms, and 3 lone pairs around A. The molecular shape for this is going to be linear. See, there's a line here between X and A. And for electron pair geometry, we still have trigonal bipyramid. The bond angles for this are 90 degrees and 120 degrees. Now we move on to shapes that have 6 groups around the central atom. AX6 has 1 central atom and 6 outer atoms. And for the molecular and the electron pair geometry, we call this octahedral. The bond angle for this is going to be 90 degrees. So 90 degrees between each of these outer atoms. Alright, moving on, AX5E has 1 central atom, 5 outer atoms, and 1 lone pair of electrons on A. The molecular shape for this one is called square pyramid, and the electron pair geometry is octahedral. The bond angle remains 90 degrees. And for our last one, we have AX4E2, 1 central atom, 4 outer atoms, and 2 lone pairs of electrons on A. The molecular shape for this one is going to be square planar, and the electron pair geometry is going to be octahedral, and the bond angle is going to be 90 degrees. Now just to mention here, when we take off the outer atom so that it becomes a lone pair, we remove them in a way that it minimizes the electron repulsion between the pairs. As you can see here, we removed one here, and then we removed one here, so that these are as far apart as possible. Thank you so much for watching this video. I really hope you found it helpful. If you did, remember to hit that subscribe button and leave a comment down below. I'll see you next time.